Today we explore what next. What happens after the Mars mission and what should we be looking for? Is it wise to be putting all our eggs in one basket on Earth and then on Mars? Or should we try colonizing Jupiter and Saturn's moons, Venus or even our own moon? All this and more on Voyage Beyond Earth. Imagine the mission to Mars was a success. Although we found no traces of life, we were able to stay there in pressurized environments, protected from solar radiation, and with ice as a constant supply for fresh water. Also, the civilization on Mars has become self-sufficient, which means it's no longer dependent on Earth for food, water, or air. Yes, we might be able to make our own air on other planets. I'll talk more about this in the last episode. So, what next? Well, SpaceX has been planning for exactly that. After colonizing Mars, they've set their eyes on Jupiter and Saturn's moons, Europa and Enceladus, respectively. Although several moons of gas giants have the potential to harbor life, Europa and Enceladus are the most likely, as said by Musk himself. In 2013, the Hubble Space Telescope discovered water vapor plumes from cryogeysers on Europa. Cryogeysers are like regular geysers, but they just don't have liquid. And it's also speculated that there's a vast sea, several kilometers deep under the icy rocky top layer. The Extremophiles episode ties in well here, because we know that there are organisms that can survive in hydrothermal vents, and we also know that due to a phenomenon that causes Europa to produce kinetic energy, there's a constant supply of heat. With liquid water and heat present, all life needs are a few basic elements that are found almost everywhere in the solar system, and life is ready to go. The Cassini probe had similar observations about Enceladus. In my opinion, Kanameer is a moon that's often overlooked by these scientists. However, it's the only moon in the solar system that has a magnetosphere. And we discussed in a previous episode how important it is to have a magnetic field. Also, it is said to have a large ocean, and with its large size, geothermal heat is probably used to heat up the oceans. Oxygen has already been detected in its atmosphere, and being the largest moon in the solar system, it's even 8% larger than Mercury, so it almost certainly contains carbon and sulfur. Recall from a previous episode, there are a few basic elements that are really important for life, namely hydrogen, oxygen, nitrogen, carbon, and sulfur. So all we need is a little bit of luck. Venus has long been regarded as Earth's twin. Again, it has an atmosphere of 96% carbon dioxide and is very similar to Earth in size. However, the surface temperature is a blistering 465 degrees and the surface pressure is 90 times that of Earth. Even though it's closer to Earth than Earth is to Mars, we've only had 3 successful landings which have all stopped working within 2 hours because either the equipment was fried or it was crushed in the atmospheric pressure. But known as HAVOC, or the High Altitude Venus Operational Concept, NASA has proposed the creation of blimps and cloud cities, 50 to 70 kilometers up from the surface. Temperatures at these levels would be about 70 degrees, which is still pretty hot, but a heat-proof suit can easily solve that. The pressure is also equal to 1 atmospheric pressure on Earth, and the gravity of the planet is roughly 0.9 that of Earth. So I want you to tell me, should we really be focusing on Mars, or should we start construction of these Venus cloud cities? Now let's look at Kepler's observations of exoplanets, and see how closely they might resemble Earth. Kepler 22b was discovered in 2011, 600 light years away. It was a planet orbiting in the habitable zone of its star and had an average temperature of 22 degrees Celsius. It seemed like a water rock world and its atmosphere also looked a lot like Earth. So why are we not on a rocket making our trip there right now? Well, it's 600 light years away. A light year is the amount of time light takes to travel a year. 1 light year is 9.5 trillion kilometers. Our fastest rocket has only ever reached a speed of 16.26 kilometers per second, which is pretty fast, but still just 0.005% the speed of light. At this speed, it would take us 11 million years to reach the star. There are several other planets detected by Kepler, but they're all just way too far, except maybe for one, Proxima Centauri b, which is an exoplanet orbiting the closest star to the Sun, 4.2 light years away. Got you excited? Well, you know how I said a magnetosphere is really important? And this magnetic field is what keeps us protected from solar radiation? Well, the exoplanet bathes in 200 times more pressurized winds, so it's highly unlikely that we'd be able to live there. But could other celestial objects be habitable? Apart from planets and moons, theoretical physicist Freeman Dyson thinks so. He believes that an asteroid could have a dome-like structure where people could live in, especially asteroids that have a strangely regular orbit around stars such as the Sun. NASA's OSIRIS-REx mission is set to find out just that. It's the first sample and return mission from an asteroid called Bennu. The next theory Dyson had was to have these large mushroom lenses that would focus light and heat from the Sun into a small area on asteroids far away in the Kuiper belt. Kepler has taught us a lot. It has shown us that 1 in 10 stars have planets and gave us hope that life might not be as uncommon as thought before. So asteroids could host life, and just maybe tying in with our episode on the theory of panspermia, life could have existed on a planet which was hit by a large object and knocked out pieces of the planet all across space. On these objects in space, life could have stowed away and hopped from planet to planet. All this talk about life elsewhere, why would we ever want to leave Earth? To go and start dirtying another planet? Well, not exactly. Humans have always had the inert need for exploration. We are social and intelligent creatures. Most, if not all, have an inner calling for exploration. And of course, as species, we don't want to go extinct. You see, if a global epidemic of superbugs does not kill us in the next 100 years, a nuclear or biological war in the next 1,000 years, a supervolcano in the next 10,000 years, nearby supernova that knocks us into the sun, or a gamma ray burst that could literally vaporize us instantly and no one would even know we existed in 100,000 years, out of control sci-fi based artificial intelligence in 1 million years, and the Great Six Extinction event in 10 million years, and if all else fails, in 5 billion years, the sun will expand and engulf us. So you see, it's imperative we leave Earth. In my opinion, the first step should be colonizing Mars and Venus. Once we are on 3 planets, we would have tripled the chances of survival of the human genome, and then we can think about extrasolar travel. The next 2 episodes will be the culmination of this series, where we plan a trip to a planet on a voyage far beyond Earth.